Laboratory of Science, Innovation and Business. This is Siblabs. The infrastructure of Siblabs includes different instruments extremely useful and important for research and development work in fields of microscopy, digitization, biomaterials and colors. In this video, let us talk about colors and spectral imaging. So what is spectral imaging? Electromagnetic radiation can be characterized by the radiation intensity along wavelength. This is called the spectrum. While the electromagnetic spectrum is very wide, our eyes see only a small part of this spectrum. This part is called the visible range. Moreover, humans do not see individual wavelengths because the human eye has only 3 types of photosensitive cells with different spectral sensitivity along the spectrum. Digital color cameras are based on this model of human color vision. In cameras, the 3 sensors are sensitive to red, green and blue part of the spectrum. From here comes the well-known RGB color model. The RGB model is very successful and used almost everywhere in our displays and cameras. So, by having only 3 types of photosensitive cells in our eyes and RGB cameras, we are able to see all the diversity of the nature. And this world looks just fine, right? Then why we need more if only 3 colors are enough to survive? Here you can see red, green and yellow apples in only one color, or what we call grayscale. Using this grayscale information, you can hardly say which apple is of which color. But it is much easier if we return back to 3 colors. So the same effect will be if you add even more colors in addition to the primary colors red, green and blue. It is this simple. More colors mean more useful information and easier classification of objects. The optimal way to get color information for your object is to get the full spectrum for each individual spatial pixel in your image. This is called the spectral image. In the case of RGB image, you have 3 layers of an image where each layer represents one of the primary colors. In case of spectral imaging, you have much more layers, which result in a 3-dimensional spectral image called a spectral cube. In this cube, the x and y axis are spatial coordinates defining the location of a pixel in an image, while the z-axis contains color information representing spectrum of each individual pixel. Spectral imaging is a very powerful tool in agriculture, biomedical imaging, geoscience, surveillance, art and cultural heritage preservation. So, how to do spectral imaging? The principle of spectral imaging is quite simple. There are several ways to do it. However, the main problem with spectral imaging is how to do it easily, quickly and accurately. Recently, our laboratory has bought the state-of-the-art spectral imaging instrument from a Finnish company, Spectral. The instrument allows making fast and extremely accurate spectral imaging. Moreover, the instrument is so simple in its use that it can be handled by non-professional staff. The principle of operation of this instrument is as follows. The instrument has 2 main parts, a camera and a scanner. The camera is not a conventional RGB camera, but a specially designed camera which scans your object 1 line at a time. The camera takes an image of a single line on an object, and each pixel on this line is split into a form of a spectrum. This is done using a prism or a diffraction grating. The spectra are recorded by the camera sensor, as you see on the screen. The scanner moves and the camera scans the object line by line. In this way, the spectral cube is formed. After measurements are completed, you can analyze the spectral cube, for example, to find out spectral signatures which you can use for image segmentation or classification. Where you can use such a spectral system? For example, to distinguish different tree species, or estimate how healthy your plants are, to sort construction debris or garbage, to control the production lines, to estimate food quality, or anything else you can imagine. Now, the spectral imaging system we just presented is not only very accurate and fast, but also expensive. However, do not worry. You must use such an accurate system only at the research stage. After you have found spectral signatures for your particular use, you can build more simple and inexpensive system, for example using LEDs or optical filters to estimate spectra. The staff of Siblabs has knowledge and skills to help you and guide you step by step to solve your specific problem, to enrich your expertise in accurate color measurement and improve your business. If you have any objects you want to classify, compare or estimate their quality, do not hesitate to contact us. We will help you. Thank you for your attention. Bye.